Okay, hello class. So this is part two, chapter five, and we're going to get into section two, where we talk about estimate cost using account analysis, the high-low method, the scatter graph method, and the regression analysis. Now, a couple of these are ones that you'll actually do and use. The others we'll just make reference to. When you look in your textbook, you'll see and you'll understand what you need to do in order to utilize these different functions in order to estimate costs. All right. So how do companies estimate fixed and variable costs? So companies typically do not know exactly how much of their costs are fixed and how much are variable. It's just not a number that falls out of the sky and pops into your head. Four approaches can be used to estimate fixed and variable costs using historical information. Account analysis, which is the most basic and probably the most common. High-low method, we take the highest amount spent and the highest output versus the lowest, and then we go from there. But one of the things to be careful with on that one is the fact that a lot of times when people do, certain analysis, they take out the highest and they take out the lowest. So you have to wonder about the accuracy of that. The scatter graph method and regression analysis, which is something that you basically do in Excel. But you definitely, if you follow the steps, you come up with the right answer every single time. So what is the goal for each cost estimation method? To estimate fixed and variable costs in the form of an equation, right? So we're going back to our equation, right? One equation for this chapter, and that's what we're looking for. So the equation is, again, total mixed costs. So total mixed costs equals total fixed costs plus variable cost per unit times the number of units or that activity. So Y, capital Y, equals F plus BX. So how does the account analysis approach used to estimate fixed and variable costs? Well, this approach requires an experienced employee to review the historical account information and classify costs that are fixed or variable, right? So we need somebody very experienced, probably with long tenure in the company, to lend us their expertise in order to know what's fixed and what's variable. The fixed costs are totaled to provide an estimate of total fixed costs. The variable costs per unit are calculated by dividing variable costs by the measure of activity. The results are expressed in the equation form that we keep talking about, y equals f plus vx. So how is the high-low method used to estimate fixed and variable costs? It's a quick and easy way to estimate costs. It's typically used with another more accurate technique and uses historical information, right? So information that's already taken place from several reporting periods to estimate costs. Highest and lowest activity levels are used to form a straight line that is then used to estimate future costs. So what are the four steps in the high-low method? And you see that when we talked about, the account analysis, we really didn't get into any numbers. It was just kind of like a basic overview of what's going to be done. So don't think like, hey, oh, he said it was four methods, but we only went over three. Well, that was the first one. This is the second one. So what are the four steps for high-low method? So number one is identify the high and low activity levels for the data set. So all you do is just look back and you find the high and you find the low and you go from there. Calculate the variable cost per unit, right, which is lowercase v. Calculate the total fixed cost, which is lowercase f, and then state the results in the form of equation, which again is capital Y equals f plus vx. So here's step one. Identify the high and low activity from the data set, right? So the high activity you see here is going to be 6,000, and this is probably like 375,000. I don't know. It's just an estimate. When we go to the next slide, you'll see exactly what the number is. Lowest activity looks like it's right there. So 3,000 units produced and probably about $200,000. Or looks maybe a little bit less, but let's just see what the numbers are. Just graphed out to show you, and then you get your estimate. So calculate the variable cost per unit. So you take the cost at the highest level, which is right here, minus the cost at the lowest level. So if my highest level, and it's not in this instance, was 700,000, that's what I would put. And the cost at the lowest level was 100,000, that's what I would put there. And then you take the highest activity level, so let's just say it's 500 units produced, minus 100 units produced is the lowest activity, right? So the highest minus the lowest, in terms of cost, and then the highest minus the lowest in terms of activity level. And these are the numbers that we came up with, 380,000. So let's look back and see, is that accurate? Yeah, 380,000 right before that 400,000 mark. That's accurate. Minus 200,000 at our lowest point. You see 200,000, it's right there. 5,900 units versus 2,900. What we see right here, it's just before 6,000, so 5,900 seems about right. And here the lowest is right before 3,000, so 2,900 seems about right. And so when you want to calculate your variable cost per unit, we've come up with $60. So we've done step one, and we've also done step two. It flies by. So calculate the total fixed cost. So after completing step two, the equation line is partially complete and stated as y equals f plus 60x. But we need the rest of our information. The goal of step three is to calculate a value for the total fixed cost. So select either the high or low activity level and fill in the database to solve for f, right, which is the low activity level used here. So on here, we put $200,000 on the side of y for the total fixed cost, right? So our 200, it comes from right there, right? So that's our 200,000. And why do you put it on that side? Because we're solving for total fixed costs. And then we have equal, we have our fixed cost, but we don't know that just yet, plus 60. Now that's where did our 60 come from? That's our variable cost per unit. And we have 29 units. How do we know we have 2,900 units? It stems from right there at that lowest level activity, and we verified it right there. So 2,900 is our level of activity. So you take 60, you multiply it by 2,900, always check my math, then you come up with 174,000. Now if 200,000 was on the opposite side of this equal sign, when we move $200,000 to this other side, remember, if it's a positive, it needs to change to a negative. If it's a negative, it needs to change to a positive. But since it's a positive on this side, it changes to a negative over here, right? Or negative in the sense that we're going to take that and we're going to subtract the product of 60 times 2,900, which is 174,000. So now we realize that our total fixed cost is going to be 26,000. So we we identified everything. We came up with our variable cost per unit, which is $60, and then we got our total fixed cost, which is $26,000. So now we move on to our equation, right? So step four, state the results in the equation form. Again, y equals f plus vx. You have to remember that formula. It's the only formula that we're basically using all chapter. So using the data from steps 2 and 3, we can now state the equation as y equals, right, 26,000, that's going to be our fixed cost, plus $60, that's the cost per variable unit, and then X is going to be the activity. So now no matter how many widgets or bikes or tables we make, if that's our equation, and we say we make 5 bikes, bam, 5 goes there. If we make 10 bikes, 10 goes there. If we make 1,000 bikes, then the number goes right there. Hopefully that all makes sense. So what is the potential weakness of using the high-low method? Well, this approach only considers the high and low activity levels in establishing an estimate of fixed and variable costs, right? It could be extremely skewed. These points may not represent the data as a whole. Maybe that information that's right in the middle in the nitty-gritty that represents it as a whole. Cost accountants often throw out one of the highest and lowest points and use the next highest and lowest points to perform the analysis, right? They say, okay, we don't want the high, we don't want the low, we want the next two in, and we'll use those. So the scatter graph method is used. So how is that used to estimate fixed and variable costs? So one, you want to consider all data points. Two, you want to require plotting all points on a graph and then fitting a line straight through the points, and you'll see that line momentarily. Is a visual method that allows accountants to identify unusual data points called outliers, right? So if we have 1,000, 3,000, 4,000, 2,000, 6,000, and all of a sudden we have 133,000, that will be called an outlier. Tends to yield a more accurate result than the high-low method. So what are the 5 steps of the scatter graph method? Well, step 1, plot the data points for each period on the graph. Number two, visually fit a line to the data points and be sure that the line touches that one of the data points. Step three, estimate the total fixed cost, which is going to be that lowercase f. Step four, calculate the variable cost, which is the lowercase v. And step five, state the results in a form of equation, our favorite chapter 5 equation, y equals f plus vx. So here's our step one, plot our data points. You just take your number 2 pencil and draw a little circle, right? If you don't have artistic ability, maybe your circles suck like mine, but it shouldn't be too hard to plot them on a graph that looks like this. So step two, visually fit a line to the data points and be sure that the line touches one data point. It touches that data point right there. 3,000 units produced at $200,000 and it's going straight through, and you can see how close they are to the line. So if you saw something up here, way down here, then that's an outlier. You have some problem there. You're going to need to do some type of research. So step three is to estimate the total fixed cost, lowercase f. This is the point at which the line meets the y-axis. So the graph on the previous slide shows a y-intercept of approximately 45,000. This step will always be an approximation, right? So it was funny. I was like looking at this thing, and they said a funny way to remember the which axis is which is the x-axis is horizontal, and they said x is Beyonce to the left, right? So left and right, and then y is to the sky, right? So y is vertical, it's to the sky. So y-axis is vertical, y to the sky. X-axis is to the left, or to the right, whichever one Beyonce wants to say. So remember, x-axis is going horizontal, y-axis is going vertical, right? So let's go back to our graph though, and you see it when they say where it intercepts the y-axis. So y-axis, this is the y-axis. So they said 45,000. So you see, and it's an estimate, right? So don't say, well, I don't see a 45,000 on there. It's slightly lower, and it's this line right here, slightly lower than 50,000. So that's where they're getting the 45,000 from. So step four, calculate the variable cost per unit, which is lowercase v. After completing step three, the equation line is partially complete and stated as y equals 45,000 plus vx. Well, why 45,000? Because we've already solved for that, but we haven't solved for v or for x, which is going to be our actual activity. So the goal of step four is to calculate the value for which the variable cost per unit. So use the data points the line intersects and fill in the data to solve for v. This point often differs depending on how the line was drawn, right? So how straight or shortened up your line was, it may vary. So use the July data for this example. That July data, because after I went through the PowerPoint and reviewed it and everything, look in your book. I think it's page maybe like 251 or something like. I'm not sure, but it has a thing in your book that shows how these numbers how they line up, and 3,500 does line up with 230,000. So you'll see that in your textbook. So y equals 45,000 times Vx, so 230,000, right? So that's going to be we're going to have that on the side for our total fixed cost. And then we have 45,000 as our fixed cost plus V times 3,500, right? So, you're going to take that 230,000 just as we did in the last equation, put that over there, subtract that 45,000 from it, and we come up with V, right, equals 52.86. Then we stated an equation, right? So y equals f plus vx, same equation we used the entire chapter. Y equals 45,000 plus 52.86 times x. That is your equation. No matter what your level of activity is, it's going to go where the x is, and you're going to solve for that equation, right? So you take 5286, you multiply it by whatever x is, and then you add that to 45,000. Remember your order of operation that you have to do the multiplication prior to doing the addition. So how is regression analysis used to estimate a fixed and variable costs? Regression analysis also fits a strategic straight line to set a data point used to estimate fixed and variable costs. Uses a series of mathematical equations used to best find the best possible fitting line to the data points. Computer software such as Excel is often used to do the calculations. If you want to do extra credit, do plot it out in the book and then send the regression analysis to me. I'll accept that. Results are presented in the equation y equals f plus vx, just like the others. And for Bikes Unlimited, it is y equals 43,276 plus 53.42 times x. All right. So summary of the four estimation methods, you can check those out on your own. We won't go over the other slides due to the sake of time, but you can check those out. And as always, have a good day and a great week. Look at your announcement and it'll let you know the other things that are due for week 5 and chapter 5.